All right, ladies and gentlemen, we're going college style for these notes. College style means you have a notebook and you just basically have to write down what the professor says. There's no guided notes. This is typically how many colleges run. Okay, so in this quizzes, you're going to be practicing simplifying radicals and multiplying radicals. One of the things we have to talk about is you can go ahead and write this in your note, in your OneNote or on a sheet of paper. When can we have negatives under the radical? Let's think about this. For example, if I ask you, what is the square root of -9? Hopefully you remember from Friday that we can't have, if it's an even root, we can't have our answer being negative and we can't have the number under the radical being negative. And if you thought about, well, in this case, why not? There's nothing times itself. If I did -3 times -3, that would produce the number under the radical. -3 times -3 is a +9. So I would say this cannot equal a real answer. What about if we had something like the cubed root of -8? Well, in this case, it's a cubed root, so I'm looking for a number times itself times itself. And if I consider -8 as -2 times -2 times -2, a negative times a negative times a negative does maintain a negative. And so my answer is actually -2, and that is a real answer. In fact, on your quiz, you would classify that as an integer, a rational number, and real. So real answer, check. So the key is, when can we have negatives under the radical? When you have an odd root. Just like this skeleton right here. And that's key, important to know. If you see an even root, like this guy right here, you would say, nope, not a real answer if you saw a negative under the radical. Okay, the next thing we're looking at is multiplying radicals. So if I was in college, my professor would be like, this is concept A. I miss college. This is concept B. Concept B is we are multiplying radicals. And important terminology that we have to be aware of, and you would see this in your textbook as you're practicing, or you should be able to see this hopefully on the quizzes. When multiplying radicals, something to make note of is the variables represent any real number. It's really important to be aware of. So if I have x, x could be -2. So keep that in mind. The first important thing you need to know is the rules of radicals. You can multiply if you have the same root. So like square root of a times square root of b would be square root of a times b. Or you could say cubed root of a times cubed root of b is equal to cubed root of ab. So important pieces to understand. You can only multiply when radicals have the same root. So like in this first one, it was a square root and a square root, or a cubed root and a cubed root. Okay, let's get to some examples. So let's go ahead and call this example number 1. If I have something like the square root of 18 times the square root of 24. You could just multiply 18 times 24, but what if I gave you this on the non-calculator portion of the test, which I would? Well, then you would want to be looking at it and say, okay, what if I factored this first? And the first thing I would ask is, are there any common factors in 18 and 24? Hopefully you're saying, yeah, they both share 6. 18 is 6 times 3. 24 is 6 times 4. So rather than multiplying those out, I could just multiply it in factored form. 18 is 6 times 3. 24 is 6 times 4. And if I look at 4, I could break that down also. Multiplication's commutative, so I can switch these guys. I'll call this 6 and 3. And if you're using the prime factor method, remember when you have two of the same number, you can say that's a perfect square, take it outside of the radical. If you're more of a perfect squares person, you might have seen the perfect square 36 and you might have seen the perfect square 4. Either way, when I'm at this point in my math, I have to keep going. So if I was using the other method, I would now separate the square root of 4 and call that 2. If you were using the factoring prime factorization method, 4 is really 2 times 2. So now I see, again, 2 of the same number. So I'll cross it off, take it to the front. And now look how easy that was. We did that without a calculator, 12 root 3. Let's do 2 more examples. The next one would be, what if we have some variables? And for example, if I have the square root of, let's say x to the first, multiplied by the square root of x cubed, you could do the factoring tree, but you might want to use your rules of exponents here. When I multiply two numbers with the same base, I add the exponents. So this would create an x to the fourth. And then you decide which method you would like to go. You could break this down into x times x times x times x. And again, you're looking for 2 of the same. So we C2, take out an x, C2, take out an x. And my answer is x squared. Since x could represent any real number, I want to stop and think, do I have to put absolute value around it? No, because any number squared creates a positive answer. So I'm golden on that. And that would be my answer. Again, if you're a perfect square type person, you could have said x to the fourth is really x squared squared. So it is a perfect square. And so I could just go ahead and take that square root and call it x squared. Either way, you need x squared. Let's do one more advanced example, and then you can go ahead and fly through the quizzes. What if we have, this is B, okay, so that was example, what did I call that? Example 1, this is example 2. Whew, I feel like I'm back in college. Example 3, if I have 3 square root of 7x cubed multiplied by 2 square root of 21x cubed y squared. First, I'm going to check it's a square root times a square root. Sweet, I can multiply. What do you do with those numbers on the outside? You multiply them together. So I have 6. And then the numbers underneath, let's go ahead and show that we're going to multiply 7 times 21. I'm just going to write it like this for right now. X cubed times x cubed. When you're multiplying two numbers with the same base, you add the exponent. So that's x to the 6th. And then y squared. Now, as I'm working, I see that it's a square root. So I need perfect squares. Or if you're a factor person, we need 2 of the same factors. And actually, it's kind of a mix of both. But if I look at 21, I see that that's 7 times 3. So looking at my number, 7 times 7 times 3, voila, I can take that 7 to the outside. And when you take it to the outside, you might be asking, what do you do with the 6? Just multiply. This is all a multiplication problem. But I still do have that 3 underneath. So just so I'm simplifying my work right now, I have 42, and then I have the square root of 3x to the 6th y squared. Now you can do your factoring. You could break down all the x's. You might also be more of a perfect square person. X to the 6th is a perfect square. 2 goes into 6 evenly. It goes in 3 times. So I could go ahead and say x cubed. Or I did a lot of thought bubbles on Friday's notes. You might be thinking x to the 6th is x cubed squared. And if I was putting that in there, I could see the 2 cancels out 2. So I have the x cubed on the outside. Now I do have to stop and think, this is an even root. So should I have absolute value around my answer? And the answer is yes, because if x is a negative number cubed still would make a negative answer. And if you have an even index, even root, then you need absolute value if you have an odd exponent. And then y, if you're more of a factoring person, y is really y times y. And I won't say that. Y squared is really y times y. So I'll just replace it with y times y. And now I found 2 of the same. So I can bring it out But again, when you bring it out, if it has an odd exponent, needs those absolute values. So on the quizzes, it would look like 42 x cubed y with absolute value times the square root of, I got rid of that guy, 3. Okay, go ahead and practice. Have a great day. Adios.